Hello and welcome, ladies and gentlemen. We are back in packet 3. We're looking at activity 3.4. This one is called bisecting an angle, and we are going to do just that. So I'm going to go ahead and read this paragraph for you. Just as line segments can be bisected, angles can be bisected too. If a ray is drawn through the vertex of an angle and divides the angle into two angles of equal measure or two congruent angles, the ray is called an angle bisector. The construction used to create an angle bisector is called bisecting an angle. Okay, so one way to bisect an angle is using patty paper. It says that here, and then so we have this example. Okay, so draw an angle on the patty paper, fold the patty paper so that the ray lies on top of, the rays lie on top of each other. The fold should pass through the vertex of the angle. Once open the patty paper, the crease represents the angle bisector. So basically, you're just taking the paper. You're taking the paper with your angle on it, you're folding the angle in half so that this ray is resting on top of this ray, and that your fold goes halfway through, or goes through the angle bisector. Sorry, I'm going to refocus here. Yeah, that was super bright. Sorry about that. Okay, here we go, we're good. So you have your angle here, you fold it in half so that this ray is on top of this ray, and the crease is through the angle bisector. That's you folding it, and then you unfold it, and that crease is the angle bisector itself. So then we have this little thing right here. It says, Angela states that as long as the crease goes through the vertex, it is an angle bisector. Is she correct? Why or why not? So, so if this were to have printed out correctly, you would see this little this thing. Let's see how we like this. We'd see a little thumbs up right there, but this printer actually helped us out. It gave us a nice little hint. She is indeed incorrect here, and the reason she's incorrect is because if I have an angle, she said that as long as the crease goes through the vertex, so she's saying as long as the crease goes through this point, that it's an angle bisector. Is she correct or incorrect? Well, I could fold it in such a way that it went through the vertex like that, or I went through the vertex like this, right? And those obviously don't break up this angle into two even parts. So just because it goes through the vertex doesn't necessarily mean that it's an angle bisector. It has to go through the vertex, but also, okay, it also has to actually bisect it. And so the way that you would get this mistake if you were using the patty paper is that if you were to fold it and say that your two rays weren't resting directly on top of each other. So say you folded it instead of it looking like one ray, right, it looking perfect, maybe it looked like this, and they were a little off, which means you either overfolded it or underfolded it, which would create either of these two scenarios where it goes through the vertex but doesn't actually bisect it. So you just need to make sure that when you fold those that they rest directly on top of each other. Okay, on to, that was from the last one. Here we go, on to the next thing. You can also bisect an angle using a compass and a straight edge. Okay, that's what it says right up here. And then, so here's the example. So you have, you construct an arc, place the compass at C, so that's the point of your compass. So if I were to give you an example, okay, so like a physical example, here's my compass. So you put the point on C, you make an arc that intersects both sides of the angle, and label the intersections A and B. So okay, now I have my intersections. And then from the intersections, we're just doing like we would a perpendicular bisector. So if you remember, with a perpendicular bisector of a line, okay, what you do is, if I have A and B, I put my point on A, I construct an arc that is farther than halfway, and sorry, the shadow's bad. I construct an arc that's farther than halfway. I do the same thing, I put my point on point B now, I construct another arc, and that was super poor, but then where the two things intersect, you draw a line through those, and that is the perpendicular bisector. So with an angle, the first thing you do is construct this arc, but then you're doing the same thing. You put your point of the compass on A, and you construct an arc, okay? And then you put the point of your compass on B, and you construct another arc, and where those two things intersect, you're going to draw a line through the vertex of your angle and where those two lines intersect, and that will be your angle bisector. So essentially it's the same process. So from my pen to the right is the same process as a perpendicular bisector, which you all know how to do. You just need to have this arc here first to start with that. Okay, so question 2 says, construct the bisector of angle A. Use patty paper to verify your construction. Unfortunately, I don't have patty paper to verify the construction, but we can do this. Okay, so I'm going to put the point of my compass on point A here on the vertex, and then construct an arc that intersects both lines of my angle. So then we'll go ahead and label this B, we'll go up here, label this as C here, okay? And so the nice thing about angle bisectors is you don't ever have to actually change the measure of your arc, because I just made this arc, and without having to change it, I can move this a little bit and then put my point on B, construct something out here, and then put my point on C and construct another arc. And where those intersect, now I'm going to use my straight edge here and go from my vertex out to that intersection. And then this would be my angle bisector. Okay, so that's just following the process that they had up here. I just did that exact process step for step there. And then, yes, I have this. So now 3 says construct an angle that is 1/4 the measure of angle H. Explain how you performed the construction. So first thing that I'm going to do, so if you guys will remember, so if I have 1/2 of something, and then I take 1/2 of 1/2, so here's an example just with a drawing, okay? If I have a pizza or a pie, whatever, pizza pie, and I cut it in half, and then I want half of 1/2, that leaves me with 1/4. So what I'm going to have to do is I'm going to have to perform this angle bisection. I'll have to do it 2 times instead of just once. So for the explain how you perform this construction, that would be how you explain it. You're just saying that you did 2 angle bisections. Okay, so I'm going to do any arc here. I'm going to make this one a little bit smaller. Okay, and I just need to make sure that my angle, or that my arc here, intersects both lines of the angle. Now I need to go here, put it on one of the intersections. And so I said that you don't have to change your compass length or the arc length on these. And for most cases, for acute angles like this, just about always you won't have to, but for this case you would. And you can tell, the reason I know that is because if I were to construct something from, well, basically, I can't do it. I need my bisection, or I need my intersection that I'm creating from this point to be out here in space somewhere, to be out here, right? And if I were to eyeball this, I would eyeball it that maybe my intersection is something like that, right? And so I need my intersection to be out there. And so because without changing my arc, my intersection looks like it might just be like inside the circle, which isn't necessarily a bad thing, but just for visual purposes, I would go ahead and extend this one, and maybe not that far. So I'd go out like this, okay, and then without changing my arc now to this other point, I'd do the same thing, and it looks like my prediction, my eyeballing was pretty close. Okay, so now I can go from my vertex through this line. Okay, so that's half. And so now what I need to do is I'm going to do the same thing, and I'm going to half it again. And so the nice thing is I already have this arc constructed here, so I can just make some points out here that intersect. 1 and 2 that intersect. There we go. And then I can connect these with my straight edge. Okay, and so this angle right here, if I were to label it, let's say, G and then H, and then let's just say we have an I here. So this angle GHI would be 1/4 of the angle of this whole H that we started with. And then again, our process was to half a half. And then so question 4 here, okay, question 4 says, describe how to construct an angle that is 1/8 the measure of H from question 3. Well, okay, if I'm going to start with my pizza example, right, if I take 1/2 of it, this is 1/2 and 1/2. If I half my half, that leaves me with 1/4 and 1/4. And then if I half my fourth, now that leaves me with 1/8 and 1/8. So I would need to do this same process that I did. So I bisected once here, I bisected twice here. If I bisect 3 times, that would leave me with an 1/8. And so if it helps you to think of this way, if it helps for you to think of it this way, if I have 1/2 times 1/2, that gives me 1/4. So that's why doing it twice gives me 1/4. If I have 1/2 times 1/2 times 1/2, if I multiply this number together 3 times, sorry, that 2 looks like a Z, then I have 1/8. Right, so if I cut an angle in half 1 time, it gives me half, right? 1/2 equals 1/2. If I bisect an angle and cut it in half twice, I'd have 1/4. If I cut an angle in half 3 times, it would give me 1/8 of an angle. Same thing with line bisections, right? So say I have a line that's 1 inch long, we'll just pretend, okay? If I have a line that's 1 inch long, and then I cut that in half, then I would have halves. If I cut that in half again, I would have fourths. And then if I cut it in half one more time, I would have an eighth of an inch, right? So same concept, just with angles instead of lines. Yeah, so there you go. That is how to bisect an angle. I believe that's all we have. Yeah, next thing we'll be constructing and inscribing an equilateral triangle, which is for the next thing. But for now, bisecting an angle, we know how to do that. We know how to duplicate an angle. We know how to bisect an angle. We know how to translate an angle with patty paper. We know how to do lots of stuff now. So I hope you guys have a wonderful evening. You're all wonderful people. A couple short videos today, which was pretty sweet. I hope you all have a good time. I'll catch you in class, and yeah, adios.